Hey, welcome. We're going to do task 5.6. We're going to look at proofs that use the idea of transformations, right? Especially in regard to parallel lines. If you remember in an earlier exercise, we decided that when you translate a line or anything really, when you translate a segment, its image is all of its segments are going to be parallel to the original. We also saw that if you do a 180-degree rotation, that all of the segments are going to be parallel to the original. And we saw that with a reflection, all that are parallel to the line of reflection, all of those are also going to be parallel, or the image is parallel to the original. So we're going to try and use those ideas with the proofs that we have here. So, you know, the first one that we're looking at, we're going to prove that angles 1 and 5 are congruent. So here's 1, here's 5. These are corresponding angles. And what's given is that BF is parallel to AD. Okay, so one way to do this, if we take this AD line right here and we go ahead and translate it like so, we can say that we translate it until point A, it coincides, goes right on top of point B. Then we can say that this angle 5 will coincide, goes right on top of angle 1. And that's based on our idea of parallelism and translations. The other one that we could do, let me move that back. Yeah, okay, so we put that back over there, is proving that alternate interior angles, so alternate interior angles 3 and 6 would be an example. This one and this one, those are alternate interior angles. Prove that those are congruent. And for this one, it's a similar argument where we can say that we can go ahead and translate the AD to BF, but we're also going to do a 180-degree rotation. So it's going to go a 180-degree rotation. And the 180-degree rotation for angle 6 is going to make it so that that angle 6 now coincides with angle 3. And that's that idea of rotation, 180-degree rotation, that anything that was parallel to the line of reflection is going to be, the image is going to be parallel after the rotation. So that's another way to look at it. And here's two more. Here it is. Prove that same side interior angles 3 and 5 are supplementary. So when we look at angles 3 and 5, supplementary means that they add up to 180 degrees, the measures. So in order to prove that using the transformational perspective, we can do that same thing. We can take that segment or line CD, and we can translate it until point A coincides with point B, just like we did before. Okay, and then what's going on here? There we go. Once we've done that, we can say that 5 and 3, because 5 now comes up here, right? We can say that 5 and 3 are 180 degrees because they're a linear pair. And supplementary, which means that they add to 180, has been proven because of the definition of supplementary adds up to 180, and we showed that they did. Another one, let me just see if I can kind of take this back. There we go. This is the last one, I think. Yeah, it's the last one. Here it's going the other way. It's saying, how can you prove that EF, the segment EF, or line EF, is parallel to CD? So it's kind of the inverse of the alternate interior proof. So how do we prove they're parallel? And the given is actually starts by saying that 3 and 6 are actually congruent. Right, so we're starting with the idea that those are congruent. How can we prove that the lines are parallel? And you'll use this all the time. You'll say that two lines are parallel because of alternate interior angles. They're congruent. What we can do is we can look at that idea of rotation. If we go with a midpoint of segment AB, right, and we do a 180-degree rotation of a trapezoid. So here's the trapezoid I was thinking of using. See if I can just, let's do it with this. So this, you can see there's a trapezoid here. AB looks like FD, ABFD. And if we are going to go ahead and do a rotation, a 180-degree rotation around this midpoint, we can kind of picture how that entire trapezoid rotates. Then the new trapezoid is going to be right here, right after that 180-degree rotation. And so then, once we've done that rotation, that angle 6 is going to coincide with angle 3, right? And so we've proven because the rotation, you've got angle 6 and angle 3, because those are congruent, and then we can say that EF must be parallel to CD because of that idea of parallelism and 180-degree rotation.